generated, we can feed it into this library, and it's a flexible library because we can choose the type of voice and accent that the user is comfortable with, and we can change the pitch and the speed at which the words are narrated. And we have been tested the performance. This is the performance for the caption generation quality. This is a natural language processing metrics we have used to raw CIDR and so these are the scores that we have got. For all these scores, the best case is 1, worst case is 0, except for CIDR, which best to be 10. So as per the model is concerned, this seems to be satisfactory. The CIDR score is very low because for here it values rare and unique captions over common ones. So most of our data set was not very such unique situations. So the score is it's normal when compared to other papers. The conclusion is we managed to implement a system that is able to assist individuals with low vision, and we have used state-of-the-art computer vision models which have incorporated both vision transformers as well as the language transformers, whichever is state-of-the-art. And our quantitative results are also showing us that we have some results which is better than what has been done previously, and it is setting a good benchmark for further studies. So this is it. Yes. So the dataset that we have used, there is one COCO dataset, COCO dataset. So in this COCO dataset, there is images as well as captions. So for natural language processing techniques, the caption that our model is generating and the caption that is provided in this dataset, to evaluate the performance, we have used this NLP metrics. And we have also implemented some of the pre-processing techniques such as lemmatization, stemming, and all that have been incorporated. So before getting the results, we have pre-processed the text.
Is there any simulations? How are you predicting the value? Any tool are you using regarding this? How do you calculate these values back? Okay, regarding the sales value, okay, where you have been taken, how you retrieve it?
Hello? Is there?
Yeah, are you hearing me? Okay, Dipshik, thank you. Fine. Okay, wind up now. Okay, Dipshik, thank you. Hello, Dipshik?
Yes, sir.
Yeah. It's okay. So wind up. Thank you. Next. Navneet? Are you there? Navneet, can you hear me? Yeah, I'm listening to you, but you're not hearing your voice.
No.
Now it's okay.
Just
Yeah. So you proceed.
மகனை லிக்விடேட் பண்ணணும் நான் காமிச்சோம்.
மேம் நாளைக்கு நான் ஃபோட்டோ எடுத்தேன்.
ஆமாம் சார், வேணும் சார். நாளைக்கு ப்ளே பண்ண போகிறாங்க சார் வீடியோ எந்த செஷனில் அது வந்து யார் இப்போ மந்திர பண்ணணும் அப்படின்னு சொல்லி ஏதாவது கம்ப்ளைண்ட் பண்ணால் வீடியோ நான்
ஆமாம்
காமிச்சோம்.
போடுவோம்.
அதை பற்றி
Hello, sir. May I have audio?
யா யா
That everyone, I'm Escalator from Karate Police Station in College. Today I am presenting our study that is study on synthetic data generation for improved machine learning performance and data collection. In this research, we used 4 different data sets to train a machine learning model in this way. Each model was evaluated with distinct data input to access accuracy, generalization, and correctness under various data conditions. First, introduction. Machine learning performance highly depends on having access to large, balanced, and high-quality data sets. However, in the real world, especially in healthcare, the data is often scarce, imbalanced, and noisy. This limits the effectiveness of machine learning model, leads to bias and even generalization into data sets. Next, problem statement. In particular, healthcare application faces a major challenge in collecting diverse and sufficient patient data because of its imbalance. Like more disease case than the standard machine learning models often fail generalization. That's the motivation to get our study. Objective. Our objective is the study. Our objective in this study can to generate clinically valid synthetic data and construct hybrid data sets by combining real and synthetic data. Evaluate different machine learning models across 4 data sets. Comparing their performance using different evaluation techniques like accuracy, precision, F1, and ROC. Next, existing system. We refer to the what? We refer to the study titled the study on liver disease prediction using Indian liver patient data set done by Purna Chandra Reddy. Used 583 records in that 460 with liver disease and other individuals with 169 healthy categories. Update several supervised machine learning algorithms like random forest decision tree and ANN, etc. ANN achieved highest accuracy among them as 87% using 5-fold cross validation and hybrid parameter tuning. However, this study had a key limitation. It did not address the class imbalance, which is significant in the data set. It also didn't explore the use of synthetic or hybrid data to enhance the diversity or robustness. This limitation are what our proposed system is designed to overcome. Proposed system. Our proposed system follows a 5-step approach. We start with the Indian liver patient data set from the UCI repository. Next, we generate the synthetic sample using class and gender-based parameter rates. Then we construct the hybrid and full hybrid data set. These data sets are used to train 8 different machine learning algorithms. Finally, these models are evaluated using accuracy, precision, F1 score, recall, and ROC score. The data set details. The real data set contains 583 samples. In that, Sample was done within the control range based on a clinical norms. This ensured that synthetic records are biologically traceable and diverse. And this is the parameter range. Each parameter was generated based on the class and the gender variation. This is the flow. When the programmer defined to generate 50,000 samples, it split into of 25,000 and 25,000. Based on the gender, the parameters are generated and checked for duplication. If any duplication is fine, the process will be continued until unique sample is generated. After generating each side 25,000 samples, it then converted into a CSV file. Machine learning model. In this study, we use 8 machine learning algorithms, include ensemble, traditional, as well as neural network. These algorithms are selected uniquely based on their classification tasks, such as like GPM, XGBoost, XRD, AML, and random forest, SPM, and large regression and AML. These algorithms are trained using 4 different data sets, ALP, synthetic, hybrid, and full hybrid data sets. Totally 32 models are trained. Each model is trained using 80-20 split and then tested across all data types. This cross-testing allows us to evaluate the model robustness and generalization. This is the table that shows accuracy of the 32 models respective to the data set. This column represents the model. For example, XGBoost that regular data set gives some percentage of accuracy in the accuracy score, as well as for other algorithms it is used based on
Set.
Extend the approach to other data types like categorical data, even mixed model makers. And we are also exploring EAS and EAC for more realistic generation and testing the pipeline, clinical testing, employing clinical settings for real world validation.
Good. Okay, then you will give good result.
Thank you, sir.
Are you there?
Yes, sir.
Are you ready to listen?
Yes, sir.
Yeah.
Yeah. Go ahead.